Now, let us see how we can try and remember why it is that when the second derivative of the function has a negative value, we have a maximum point, and when it has a positive value, we have a minimum point. We had worked this out. We had found the nature, the location and nature of this, the critical points or the stationary points or the turning points of this function, and did some amount of sketching of the graph. And now what we want to do is try and remember why, when we have the second derivative giving us a negative value, it's a maximum point, and when it gives us a positive value, it's a minimum point. Alright, so let's see what happens. Let us get a tangent line to this curve. Alright, we have our tangent line. Let's make some changes in terms of the thickness and color. Let's make this tangent line a bit bluish. Alright, and make it very thick. Good. Now, as I move the tangent line along the curve, you see that the gradient of the tangent is positive, but it is reducing. It's going down. Now, right at the critical point there, we have a horizontal line. I'm trying to get it horizontal, but it's kind of difficult. But for our intents and purposes, it's a horizontal line. So the gradient at that point is 0. Now you notice, as we move from left to right, the gradient is reducing. It's from positive to negative. It's now negative after you pass the critical point. The gradient turns negative. So right at this point is a maximum. It's approaching the negative. So the second derivative, when you substitute the value of x at that point, if you have a negative, it works out negative, then you have a maximum point, because that is where the gradient is going. It's going towards the negative. Right? Now, let's see what happens at the other point. As you move from left to right, the gradient is negative, but it's swinging upwards. It's becoming positive. Right? The gradient is negative. It's going in the positive direction. It's increasing. At the stationary point, it's going to be horizontal, 0 gradient. And then, after you pass the stationary point, going to the right, it swings upwards, positive. So, here, it's turning from negative to positive. So that's why when you find the second derivative and substitute the x coordinate at this point and you get a positive value, then it's a minimum point. Because the reason, as you move horizontally from left to right, the gradient, the derivative, second derivative, the gradient is swinging in the positive direction. It's going positive, alright? So you see that? Alright, before we end this, notice at some point the gradient of the line swings, the gradient line swings so that the gradient is more and more negative, but it's slowing down, and then at some point it stops and starts to swing to the positive direction. Right? You see, down and then swing. So the swinging is negative, then it stops and then starts to swing back towards the positive. The point at which that occurs, you should remember that is called the point of inflection. Right within this region here is the point of inflection. Alright? So those are the things that we wanted to look at in this video. So that will be it for now. Any questions, comments and so on? Put them in the comment section and I will see you later.